Hey, I'm glad you made it. Welcome to this video on inequalities. So this is a concept that we will discuss here that leads you towards finding a solution for inequalities. The first inequality that we will solve in this video is called linear inequality. 3 times x is greater or equal to 0. So what that means that we are finding any possible value of x that would satisfy the statement. So by inspection, for example, if we select x is equal to -1 and plug in back into this inequality, you will see that 3 times -1 is -3, and this is definitely not greater or even equal to 0, a false statement. However, if you choose x is equal to 0, all of a sudden you're able to balance this statement because 3 times 0 is 0 and 0 is definitely equal to 0. So, true statement. Similarly with x is equal to 1. You plug in and you know that 3 times 1 is 3, so definitely it's greater than 0. So from this point, you would start making a conjecture that there are more than a finite number of solutions to this inequality. Solving a linear inequality requires to isolate for x. Just recall working with a linear equation. You have to rearrange things around using laws of equations by adding the same value to both sides. Take away the same non-zero zero value. It doesn't make sense to take away 0 value. So taking away the same value from both sides, multiplying both sides by non-zero value, and dividing by non-zero value. So those are the rules for equations. Inequalities have slightly different set of rules. We'll discuss that a little bit later. So to solve this inequality for x, you will have to divide both sides by 3, which is a positive number. So this is why you have 1x is greater or equal to 0. So this is the statement in simplified form already. So this statement says that any x that is equal or greater than 0 satisfies this inequality. So you can use notation, inequality notation, to make the statement that the solution shows x is greater or equal to 0, or you can opt for interval notation, and please note that we say x is element of the following interval. So that square bracket defines that it begins from the lowest value here. So x is part of the solution. So you have to emphasize that by using square brackets, comma, positive infinity. So any number from that interval gives you the solution to this equation. Now we'll move on to slightly different type of linear equation. Okay, so this is the inequality 3x plus 1 is less than x minus 5. So this example shows an inequality that does not have that second possibly greater or equal or less or equal. So this is simply just x, 3x plus 1 is less, this is important to make note of that, than x minus 5. So in order for us to solve it, we will have to rearrange it and solve it and isolate it for x, maintaining that inequality symbol throughout each step. So first, you move x to the other side by subtracting x from both sides. So this is why you see 3x minus x. And then you would move 1 to the right hand side, and this is why you see -5 minus 1. Then 3x minus 1x gives you 2x, and -5 minus 1 gives you -6. Divide both sides by positive number, and 1x is less than 3. So showing this solution on the number line, you will emphasize that -3 is not part of the solution, so therefore that circle is not filled in. It's a hollow circle. So this is the convention that we follow here when we show the graphical solution using a number line. When you fill in the circle, that means you accepting the endpoints of the interval. If the circle remains open, that means not the beginning value of the interval. So -3 is definitely not part of the solution. And using interval notation, you say x is element, and then use round brackets. You never use square brackets to include infinity symbols. So -infinity, comma, -3, open brackets. So this is the solution to this inequality. And now we will move down to this example, a little bit more complex. But the idea is here the same. Find an interval that would satisfy this inequality. So recall the rules that we have to follow while working with inequalities. We'll quickly remind ourselves about the following. You can add or subtract, like with equations. Add or subtract any number. Obviously, you're not going to do addition of 0 or subtracting 0. Then you multiply or divide by both sides of an inequality by the same non-negative number. This is very important. Supposedly, I have a statement. 1 is less than 2. True statement. When I multiply this inequality by -1, I would have -1 less than -2. And you know that this is a false statement. So when you multiply an inequality by a negative number, you have to flip the sign. For example, if I have 1 less than 2 times -1, so -1, and now you've changed this relation into the opposite. -1 is greater than -2. So this only works when you multiply inequalities by negative values. When you, however, multiply by positive number, you maintain the same relation. So since our question has some fractions, and we are not very excited about seeing fractions, so think of the following. Find a common denominator. You have 3, you have 2, so this is why you choose 6. So you would multiply by 6 both sides of this inequality. So since 6 is positive, so you don't have to change the sign. And then you would do the distributive property here. So 6 times fraction here, 2 over 3. So you're thinking 6 times 2 over 3 really is 12 divided by 3, so this is why you get 4. 4 in front, no more brackets, and 6 times 1 over 2 gives you 3. There you go. So this is why you have 4 times x minus 1 is less or equal 3 times x plus 2. Now you truly will do the distributive property. You multiply 4 times x, 4 times -1. So there you go. 4x minus 4 less or equal 3 times x, 3x, and 3 times 2, 6. And this is very similar to the one on the left side of the screen now. You will have to move things around. So keep 4x on that side, for example, move 3x to the opposite side. So this is why you have 4x minus 3x. With given 6, you add 4 to 6 because you move -4 to the opposite side. So by adding 4 to both sides, you have 6 plus 4. So 6 plus 4 is 10. So this is why you have x is less or equal than 10, which means you must include the 10 as the beginning of the interval, and you show on the number line all values that are less than 10. So this is why you go to the left. Using interval notation, we have the following statement. X is element of negative infinity, comma 10. Please note, square brackets. So this is the example, the last example of solving linear inequalities. The next example will be on finding solution to quadratic inequalities. So the values, the variable x will be to the power of 2. So let's start the next example. Quadratic inequalities, you have 2x squared minus 5x minus 3 is greater or equal to 0. So we have two options here how we can solve this. We can solve quadratic equation, find x values where it would be equal to 0 and then work it from there. This is the second degree inequality, so you anticipate to have for the most cases, 2 0 values. You also have to be aware of that you may have 1 or none. Sometimes there will not be a solution to quadratic inequality as well. Since our example provides 2 x-intercepts, we'll do it first by factoring. So just to remind you, you're looking for a product of coefficient A and coefficient C. So this is why you have 2 times negative 3. So the product is equal to negative 6. I hope you can see that on the screen. So 2 times negative 3 is equal to negative 6. The sum of 2 missing numbers is equal to negative 5. So by trial and error, the two numbers are negative 6 and 1. When you add them, you get negative 5. When you multiply to negative 6 and 1, you get the value of the product negative 6. So let's continue factoring. So from the trinomial, the next step is to exchange the middle term in terms of negative 6x, negative 6x, and I'm using the magic pen. This is why it does. So the point here is negative 6x plus 6 would be replacing negative 5x. So this is where that comes from. Okay. So further, you have 4 terms to work with, and now you group them in 2 groups of 2, no particular order. Look for the common factor. Since I have 2x as a common factor here, for the last 2, there was no common factor other than 1. So we will just leave it like the way it is, x minus 3. Now x minus 3 is a common factor for both terms, so that goes out. X minus 3, in goes 2x from the first and 1 from the second. So this is the factored form. So now our inequality is stated in that nice factored form. So you're solving the following statement. Product of 2 numbers has to be positive. So you would do cases if you were to use algebra. Case 1, both numbers are negative. Case 2, both positive, or vice versa. Or by simply using the knowledge of quadratic graphs, you would say the following. Coefficient A is positive, so your graph has to open up. This is the behavior of second-degree polynomial. So the 0 values are negative 1 over 2 and 3. So what you see here on the screen in blue is just a sine wave that represents the values of a function on 3 different intervals. So any number less or equal to -1/2 would produce positive value for y. Any number in between -1/2 and 3 will produce negative value for that product. And any number that is 3 or greater than 3 would also give you positive result. So this is why our solution is x is either less or equal to -1/2, since we're looking for possible solutions that are greater or equal to 0, or x is equal to 3 and or greater than 3. Using interval notation, we have to emphasize that square brackets are to be used. -∞ to -1/2, union symbol, which represents or, x is element of the next interval as well, 3, including 3, comma, positive infinity. So you have options here. Either you say this or that inequality, or you can use interval notation where you take care of also 2 possible regions on the x-axis. 2 ½ including the end, or starting from 3 towards positive infinity. Excellent. So that's one case where we did the solution by factoring. The next one is to use quadratic formula. For those who still need to be reminded, I have it right here for you, so you don't have to worry and say, quadratic formula, I don't know this. So this is basically a formula where we identify first coefficient A is 2, coefficient B -5, constant C is -3, so this is what you have right here. Plug in directly into the formula for A, B, and C. Follow the instructions, which is about simplifying it. So negative and -5 gives you just 5. Then you do the math inside. You have 25 plus 24. So this is why you have 49. So you have possibility for 2 roots. When you simplify square root 49, you get 7. So x is either 3 and x is either -1/2. You must get the same solutions, right? Whether you do factoring or quadratic formula, the solution has to be exactly the same. So this is why knowing where the x-intercepts are at -1/2 and 3, including the endpoints, because you have the inequality greater or equal, now you can see that the interval is essentially duplicated, because this is the same solution, it's just a different method. Less than equal -1/2 or greater or equal to +3. And the last example will be cubic inequalities, and then we will move to the part 2 video when you will work with rational inequalities. So let's move down to the next example. Cubic inequalities. For cubic inequalities, solutions is found only, we will be working with the type of questions where you can factor it. If you can factor a cubic polynomial, you can find intervals for x is supposed to be greater than 0 or less than 0, so that is not a problem. In case the cubic polynomial is not factorable, then the solution is used either by approximation, or you can use your calculator to find relatively close value that would satisfy the inequality. In the problem presented here in this video, there is a solution to this inequality, and it can be done by factoring. So, first thing you do, you say, let this be equal to 0. Okay, so you're looking for x-intercept. It's very similar setup to solving equation for cubic polynomial. Since the leading coefficient is 1, the constant is 6. When you multiply 1 times 6, you get 6. So the factors of 6 are listed here. And the only possible solutions that you will have will come out from this 2, 4, 6, 8 possible values. So if I need to factor this polynomial, these are the possibilities only that I can exercise. So by inspection, you just select any number, -1, +1, -2, +2, 3 or 6 plus or minus, and by replacing the value of x, if you get 0, you know that x minus that number is a factor. So this is why at -1, the value of the polynomial is 0. So x minus -1, which is x plus 1, is a factor. Then you do this further by inspection using value of x is equal to 2. And that gives you the value of the polynomial 0. So therefore x minus 2 is another factor. Finally, the last possible solution, 3, by inspection also. Try and error. There is nothing here that should sound mysterious. Plug in, does it work? Fine. If it doesn't, move on to the next number. And the possibilities are here: -1, +1, -2, +2, -3, +3, -6, +6. Cubic functions, so I already have 2 factors. This is the last factor that you can have. You cannot have more than 3 factors for a cubic equation. So we have changed this expanded equation into factored form. To solve this inequality, we will be using the end behavior of cubic polynomial. So you start from -infinity, then you bounce back to another x-intercept at 2, and then you have to turn around and move and cross at 3. So you will be crossing x-axis at -1 and +2 and +3. Right. This is the direction in which a polynomial cubic function behaves if the leading coefficient is positive. Our leading coefficient is 1. So this is why we can concur that this is the behavior of this particular polynomial. So whenever the graph falls above x-axis, you consider this to be greater or equal to 0. So we have interval here in between -1 and 2, or greater or equal to 3. So using interval notation, double inequality, or you can use this type of notation where you include the endpoints. This is why you have square brackets on both ends and the union of 2 intervals. So x is element of the following interval: -1, 2, close on both ends, or x is element of the interval where x value starts with 3 and goes all the way to +infinity. So this is basically the idea that you have learned here on how to solve inequalities of 3 types: linear inequality, quadratic inequality, cubic inequality. The higher order inequalities would be solved in the same fashion only if you can factor a polynomial. That's the necessary conditions. You will not be asked a question if you cannot factor to solve that inequality. Most of the time, it would be factorable. So I hope you have enjoyed this video, and I hope that now you will be able to successfully solve polynomial types of inequality. And in the next video, we will teach you how to find a solution to more complex problem which is involving rational inequalities. So thank you for your attention, and I see you next time. Bye-bye.